All right, in this video, we're going to introduce complex numbers and looking at performing arithmetic operations, addition, subtraction, multiplication, and division with complex numbers. Actually, I think we'll save the division for the next video, just to have this not go as long. So complex numbers arose from the need to solve quadratic equations such as x squared plus 1 equals 0, where we don't have any real numbers of x that we can square them and add 1 to it and get 0. So even if we put a negative 1 in for x, negative 1 squared is positive 1, and positive 1 plus 1 is 2, not 0. So the solution to the above problem would be to subtract 1 from both sides and then take the square root of that. And the square root of negative 1 is the imaginary unit I. So anytime we have a square root of a negative number, we're getting imaginary numbers involved. So some properties of this imaginary unit I is that I squared is negative 1. And if c is a real number that's 0 or higher, in other words, it's not negative, then the square root of negative c, so like the square root of negative 2, is I times the square root of 2. So with this negative here, we can actually pull it out as the square root of negative 1 times the square root of c, and the square root of negative 1 is our value of I. So a complex number is simply a real number paired up with an imaginary number. So it's in the form a plus bi, where a and b are real numbers and I is that imaginary unit. So a pure real number can be written as a plus 0i, and a pure imaginary number that doesn't have a real number attached to it can be written as 0 plus bi. A is called the real part, b is called the imaginary part, and we can add, subtract, and multiply complex numbers a lot like we can for real numbers and things like combining like terms. However, keep in mind, especially with multiplication, that if you come across I squared, we can simplify that and substitute a negative 1 in its place. So example 1, we're going to perform each indicated operation and write our answers in the standard a plus bi form. We have 1 minus 2i, that complex number, minus 3 plus 4i. So we can drop the parentheses by distributing this negative to the 3 and to the 4i. So we get 1 minus 2i minus 3 minus 4i. And then just combine like terms. In this case, combine the real numbers. 1 minus 3 is negative 2. And then the imaginary numbers, negative 2i minus 4i is negative 6i. And here's our answer. Part B, multiplication. So distributing through, 1 times 3 is 3, 1 times 4i is 4i, negative 2i times 3 is negative 6i, and negative 2i times 4i is negative 8i squared. And 4i minus 6i, we can combine these two in the middle to give us negative 2i, and then we can substitute this I squared, a negative 1 in for it. So then we have negative 8 times negative 1 is positive 8. So now combining 3 minus 2i plus 8 gives us 3 plus 8 is 11 minus 2i. Part C, square root of negative 3 times the square root of negative 12. For the square root of negative 3, it's I times the square root of 3. So square root of negative 1 times the square root of 3, and the square root of negative 1 is I. And then the square root of negative 12 is the square root of negative 4 times the square root of 3, and the square root of negative 4 is 2i. So the i's outside the radicals just are dealt with these negatives here, and then the square root of 12 is 2 square root of 3. So multiplying this out, I times 2i is 2i squared. Square root of 3 times the square root of 3 is the square root of 9. 2i squared is 2 times negative 1, which is negative 2. And the square root of 9 is 3, so negative 2 times 3 gives us negative 6. All right, part D, this time it's the square root of the product of negative 3 times negative 12. So not exactly the same because we're not separating the two. We have them all together inside one square root. So square root of negative 3 times negative 12, well, negative 3 times negative 12 is 36, and square root of 36 is 6. So notice the difference that when it's the square root of a product, not with complex numbers, not necessarily going to be the same as the product of the square roots. So be careful there. If you can simplify inside the square root, please do so. All right, last up, part E, we have x minus the expression 1 plus 2i times the expression x minus 1 minus 2i. This one, you just have to keep track of your multiplication, and let's see what happens. So we multiply this out, x times x is x squared, and then x times negative 1 minus 2i is negative x times 1 minus 2i. And then distributing this negative 1 plus 2i in our first group here, negative, the expression 1 plus 2i times x is negative x times 1 plus 2i. And then we have negative 1 plus 2i times negative 1 minus 2i, where the negative times the negative gives us this positive here, and then 1 plus 2i times 1 minus 2i, we'll take care of that in a little bit. So quite a bit to multiply out and simplify here in this first step. So when we do that, the negative x times 1 is negative x, the negative x times negative 2i is plus 2ix, negative x times 1 is negative x times 2i is negative 2ix, and then multiplying out 1 plus 2i times 1 minus 2i, we get 1 minus 2i plus 2i, and then minus 4i squared. So let's see what we have. Well, the x squared, there's nothing to combine with that. We have negative x here and negative x here. That makes negative 2x, and there's no other x terms. Now this positive 2ix and this negative 2ix are going to end up canceling each other out. Likewise, the negative 2i and the positive 2i end up canceling each other out. So we have this plus 1 we can bring down, and then minus 4i squared is minus 4 times I squared is negative 1. And this will give us x squared minus 2x plus 1, and then plus 4. Negative 1 times negative 4 is plus 4. So 1 plus 4 is 5. So this scary looking expression, when we multiply it all out, and really just be careful with your multiplication, so a lot of room for error here, ends up simplifying to x squared minus 2x plus 5. All right, that about does it for this video. Thanks for watching. In the next video, we'll look at how to divide complex numbers by multiplying. So see you then.